All right, so in this video, I'm going to talk about regression. This is a set of 3 videos where I'm going to talk about regression in this video. The next video, I'm going to show one way to solve regressions, and then in the other video, I'm going to solve a different way to solve. I'm going to show a different way to solve regression. So what is a regression? Well, let's say you have one variable and you want to predict another. So for example, I got data from somewhere and I contrasted people's weights or body mass in kilograms with their height in centimeters, right? And I found one person that was about 45 kilograms and was about 132 centimeters tall. In the same way, I found someone who was 70 kilos and was about 175 centimeters tall, 178 centimeters tall. I also found a person that was 110 kilograms and was about 198 centimeters tall. So I plot this, right? Now I have this plot, and that is fine. But what I would like to predict, right, would be, well, what if I find someone that's 100 kilograms? How tall, more or less, would they be, right? Or if I find someone who's above this, someone who's 120 kilograms, how tall are they? Or if I find someone that's 90 centimeters tall, 90 kilograms heavy, how tall are they? These are all data that I don't have, but I can predict. You can think of also weather data, right? If certain conditions, if certain barometric pressure in the air that correlates to some temperature, right? Given the barometric pressure, can I predict the temperature? Can I predict something else, right? So the idea here is, given one variable, can you predict another? Okay, that's the simplest way of regression. You can use this with multiple variables. So given a set of variables, so for example, price of a certain stock, time in the market, and some other variable, number of people hired, number of people fired, for example. Can I predict the value of that stock, right? So in that case, you have multiple variables trying to predict that one value. That's the realm of regression. Now, how does regression work? Well, with 2 variables is the simplest way to show it, but what you want to do is try to, with all the points that you have, because you need some data to train, some data to understand how the regression is working. With that, you want to get a line, in this case is linear regression for the line, a line that passes the closest to all points, right? So the idea here is to find this line. So if I want to find, well, how tall is a person with 90 kilograms? I'm going to estimate it around here, around that point, okay? The idea would be to find this line, but not any line will do. So more formally, the idea is that I want to predict a set of y points, a set of prediction points, given x, and x are the variables that allow me to predict that point. More importantly, given one value, so for example, 90 kilograms, I want to predict what is the function that, given this 90 kilograms, is going to give me the height or the predicted variable. So we usually denote it h of x or some function of this value. You give it 90, and then this will spit out, I don't know, 178 kilograms or something. So more generally, you want to give all the values for all the data, and you want it to predict all the outcomes. Or in particular, you want to give one value of the input, and you want to get one prediction, one number prediction for the output. So now, the other thing that is important to notice here is that because it's linear regression, I'm going to assume that the function, it's going to be some sort of straight line. And the function for a straight line is like this. It has one value here, one constant value here, and then some constant multiplied by x, right? So sometimes in school, the equation was given as something like this. Y equals b a plus bx, or something like that, or a plus mx. That's an equation of a straight line. It's the same thing here. This is y, this would be a, theta 0, and theta 1 would be m. Now, why do I give values theta 0 and theta 1? Well, because if you have more variables, it's easier in terms of math to just have variable 0, variable 1, variable 2, variable x. You know, as many values as you want with the same variable name. Why theta? Well, because in math, people like Greek letters. All right, so these thetas, theta 0 and theta 1, are called parameters. But again, I want to highlight this is just the equation of a straight line the way we have always known. All right, that is the idea of the linear regression. So again, let's go back to our points. Given our points, we want to find a theta 0 and a theta 1 that gives me a straight line that passes through the most points. So for example, here, if theta 0 is 90 and theta 1 is 1, we're going to have a straight line that will go through, I'm going to change the color of this, let's put it red, that goes through 50, 140, I believe, and 100, 90. We're going to have that line. Okay, if we change it to 80, we might have a line that's slightly different. If we change it to something else, we're going to have a line that's slightly different, and so on and so forth. So which line passes closest to all the points? For example, this one passes very close to these points, but very far from this one. So the idea is trying to find the line that gets closest to all the points. Something around here maybe, right? That is going to be the idea of regression. In the next video, I'm going to talk about how to use math to actually get that line, basically get these parameters. We want to get theta 0 and we're going to get theta 1. That's what we want to get, right? So stay tuned for the next video.